Saxon's Trig, Lesson 46, about complex roots and factoring over the complex numbers, begins on page 324. So from the title, complex, you know that we are dealing with something that has imaginary numbers in it or very complex concepts. And roots tells us that we're dealing with answers. So just as you would expect, they are going to, in example 1, give you the roots and ask you to create the equation. So their wording is, write the quadratic equation, meaning it's got x squared, x term, and a no x term, and it equals 0. That it has a lead coefficient of 1. Remember, that wording has to be clarified in there to avoid any problems. And whose roots, answers, are 1 plus 2i and 1 minus 2i. And I see very clearly there that those have i's in them, imaginary numbers, making them complex. And just like we did in the last lesson where we worked these, we were given the roots. We have an x and an x, and when we plug in those answers, we change the sign. So minus 1 minus 2i, and the second answer, minus 1 plus 2i. And we have our equation, but we need to get it simplified. So let's distribute x times x, x squared. X times negative 1, negative x times the 2i, 2xi, ix doesn't really matter. Now we move to negative 1 and multiply times x, negative x. Negative 1 times negative 1, positive 1. Negative 1 times 2i, minus 2i. Now move to the minus 2i times x. Again, it doesn't really matter the order I'm writing it. Minus 2i with minus 1, positive 2i. Minus 2i with positive 2i. Negative times positive is negative. 2 times 2 is 4. I times I is I squared. Now, I will have to fix that. But in the meantime, I have my x squared. I have a minus x term, a minus x term. So those go together making minus 2x because they both have an implied 1. So minus 1 and another minus 1 is minus 2. Positive 2xi minus 2xi cancels off. I have a positive 1. And I know this one is going to be its match, but I'm not quite there yet because I haven't fixed it. Minus 2i, positive 2i cancels off. And what is your I squared? Negative 1. Remember from your I chart, I is the square root of negative 1, but I squared, if you multiply that again, you lose the root part, and so you get to keep the negative 1. So negative 1 times negative 4 makes this positive 4, and it is the match with the 1. So 4 plus 1 then is 5, and it equals 0. And yep, double checking that that was the correct answer they were looking for. Okay, that's the only example they do of that because it is concepts that you had before. It's just now they're throwing that I in there and they assume it does not mess you up. Part B, factoring over complex numbers. So I know I'm dealing with factoring, and complex means I'm dealing with something with an I in it. And so they give us in example 2, 2x squared plus 4x plus 8, and they want this factored. Now, I can attempt to factor everything like 2x with x, and then 8 might split into 4 and 2, and whatever is here multiplies with this one, making 4. 4 and 4 can make an 8, can't make a 0. I can play with numbers. I can change the 8 to 8 and 1. That's going to give me a 2 with an 8. But no matter what I do, I can't find a factor that works. So typically, when I have a number here, rather than going through the complicated thought process of trying to factor, since we have the quadratic formula, even though it's a messy, long formula, it's faster than trying to play to find the factors. So I'm going to jump immediately whenever I have a coefficient in front of the x squared to a is 2, b is 4, c is 8, and plug into the quadratic formula, which again, and you should be memorizing it, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we fill in our b. So we have negative 4 plus or minus the square root of 4 squared is 16 minus 4 times a, which is 2, times c, which is 8, I'm going to extend that square root all over top of 2 times 2, which makes 4. And now we just simplify our numbers. Negative 4 plus or minus the square root of 16 minus 4 times 2 is 8. 8 times 8 is 64 all over 4. Negative 4 plus or minus square root of 16 minus 64. Now this is why, as soon as I see that I have a negative inside a square root, I realize why I couldn't factor, because I can't instinctively create i's in my head and make those numbers work. So 16 minus 64, sorry, I have to stop and do that calculation. So I believe that's negative 48. Let me check that. Yes, okay, so now all over 4, okay, we're getting there. So the 48 is gonna split into whatever you see to split it. I'm gonna do 4 and 12. Split the 4 into 2 and 2, the 12 into 2 and 6, the 6 into 2 and 3. I have a set of 2's and another set of 2's. So 2 pulls out, 2 pulls out, that makes 4. So I'm rewriting minus 4 plus or minus, my 2 and 2 made 4, radical 3 stuck inside all over 4. Now we're down to reducing all of the outer numbers. So I'm cramming space here to get an answer, but if I divide everything by 4, negative 1 plus and minus root 3 over 1, and then I don't need the 1 part, so I'm keeping the answers negative 1 plus and minus root 3. I'm looking for, oh, wait a minute, just a second. Their answer was at the bottom of the page. It threw me because they decided to pull a 2 out, but it still works the same way. Oh, and they stuck it in a parenthesis. That's the other thing that's weird. So we're going to separate it from the x, because it says factor. It wants the answers, not the answer in its parenthesis format. I don't know why sometimes they choose to do it this way, but I have a negative 1, the opposite of what they have, and then plus and minus, so both sets of answers with the, oh, I left something off over here. This was a negative. I failed to put my I, which is important here because I didn't write it with the negative inside the radical, so I had pulled an I out. So this should have an I here as well because the negative was inside and the root 3. So they had the I at the end. I prefer the I in the front so it doesn't get confused about whether the I is or is not inside the square root. Sometimes it's just at a quick glance, it's easy to get it confused. So I write it in front because it just feels much clearer. Okay, now example 3 on the next page asks us to do the same thing again, x squared plus 2x minus 5, and they say factor it. Now I do not have a coefficient in front of my x squared, so I might take the time to mentally stop and think, what can I use to split up 5? Well, only 1 and 5. Is there any combination of 1 and 5 that will give me by adding or subtracting a 2? Nope, so I definitely know I have to quadratic. So the a is the implied 1, b is the 2 with the x, and c is the negative 5, the no, oh, this should have equaled 0 if I'm factoring. They didn't give you the equal 0, that's okay. So now we're going to put it in the quadratic formula. Negative b plus or minus the square root of b squared, 2 squared is 4, minus 4 times a, which is 1, times c, which is negative 5, all over 2a, 2 times 1 is 2. And now we work on simplifying. Negative 2 plus or minus the square root of 4 minus times minus is actually going to change this to a positive, and 4 times 5 is the 20 all over 2. Negative 2 plus or minus the square root of 24 over 2. And then I need to split this up to see if it simplifies. Let's go 2 and 12, 2 and 6, 2 and 3. One set of 2's will come out. So our negative 2 plus and minus, the 2 that I just pulled out, and then there's a 2 and a 3 still stuck inside that goes back to 6 over 2. All of the outside numbers will reduce down by 2, so we have negative 1 plus or minus square root of 6 all over the 1, which I don't need, so I'm going to ignore that. Again, they put that answer back into a parenthesis. But I have a minus 1 where they have plus 1, the positive and the negative, and the root 6.